So InterVLAN. Okay, it's a process of communicating from one VLAN to another VLAN. So one VLAN, so if you have a VLAN, suppose VLAN 10, we can give an IP 192.168.10.0/24. Okay, any IP you can give. And if at all you have VLAN 20, we'll be giving another IP range. Okay, we'll be giving, suppose that I am giving 192.168.20.0/24. Okay, so now let me, so here you got two VLANs belonging to two different networks. So if you have two different networks, to communicate between the networks, what do you need? What do you need?
Routing.
Yes, of course you need a router. Okay, you need routing or kind of, or a router you need, or at least a layer 3 device is needed, right? Okay, so layer 3 device is needed, and so you can do the InterVLAN using the layer 3 device router. You can do it with the help of a router. Okay, so if you do it with the help of a router, that is called a router on a stick. It's called a router on a stick. A router on a stick. Okay, now you have switch, L3 switch. You have L3 switch, or it's called multi-layer switches. It's called multi-layer switches. So you can do with multi-layer switches as well. If you go with a multi-layer switch, that is called switch virtual interface. Switch virtual interface. Okay, now I'll teach you first router on a stick. So you can write the heading router on a stick. Suppose that you have a switch here. You have a switch, and that switch is connected with, say, suppose a machine in F0/1 which is participating in the VLAN, say VLAN 10. It is participating in VLAN 10 here. Okay, VLAN 10. Now suppose, so VLAN 10 has an IP 192.168.10.0/24, or suppose let me give 10.1/24 IP. Okay, now we have got another machine sitting in F0/2, sitting in F0/2, and see, suppose he is in VLAN 20. He's in VLAN 20. Now his IP address, suppose the IP address is 192.168.20.1/24. Clear? Okay. Now, so if you have these machines, then let me tell you. So here I'm gonna connect a router. So I told you that we are going to use a router for InterVLAN communication. Okay, so here you got a router. Suppose it is gig 0/0/0, gigabit internet 0/0/0. Now suppose it is connected to fast internet 0/10 of switch. Okay, now what we are going to do is we are going to split. So here you have got two networks. You got two networks, but you only got a single router interface. So what you're going to do is you're going to split it. Okay, so you're going to split it. Just a moment, guys. Okay, so guys, anyone else having any issue with the Zoom?
No, but the pixel is breaking.
What is breaking?
You can't see that clearly.
Okay, that is the issue with this VG, I suppose. Okay, so just a moment, guys. One of the students, she has pinged me. Just a moment. Let us. Okay, so guys, now shall we? Okay, so now, yes, so here what is it? Okay, so we were discussing about this InterVLAN. Okay, so now what we are going to do is that we are going to split this interface, this physical interface, we are going to split it virtually. Okay, we are going to split it virtually, or you are going to create sub interfaces. You are going to create sub interfaces. Okay, so you're going to create two sub interfaces. So what I'm going to do is that, okay, so this physical interface is now divided into two sub interfaces. Okay, so suppose sub interface, it is gig 0/0/0.1 is the sub interface. Okay, then I'm gonna mention it to participate in VLAN 10. I'm gonna mention to participate in VLAN 10. Then I'll give the IP, suppose 192.168.10.100. Clear? Okay, I have given an IP belonging to VLAN 10. Okay, now the same thing will be done to the next sub interface, gigabit Ethernet 0/0/0, suppose .2, any sub interface number you can give, .2, .3, .4, anyone. Okay, yes guys. Okay, if you want you can decrease it or increase it, and then you can listen to the class. Okay, now so it is gig 0/0/0.2. Then what you are going to do is you will assign it to VLAN 20, and you will give the IP 192.168.10, yes, 20 dot range, 20 dot, suppose 100 you are given. Clear? Okay, then one more thing what you will do is that, okay, so here the computers need to be assigned with a gateway address. So here the gateway address will be 192.168.10.100. This will be the gateway address. The gateway address will be the IP address of the sub interface. Clear? Okay, it's the same thing we are going to do it here. So the gateway address, it is 192.168.20.100. okay, and one more thing, if you do it, then done. Okay, this interface, the interface which is connected to the router, the switch interface which is connected to a router, will be configured as the trunk port. It will be configured as the trunk port. Clear? Done. Okay, so now let me show it to you. So let me take the packet tracer. Okay, and let me take a router here. You have taken a router, then say a switch, and suppose let me take two machines. Okay, and let me, okay, so let me do the pre-configurations. Pre-configuration is that two interfaces you got, FA0/1 and 2, which need to be assigned to VLAN 10 and 20 respectively. Okay, so we'll go to the config and we'll be assigning, say, interface fasternet 0/1. I'll be assigning switch port mode access and switch port access VLAN 10. Clear? Okay, so here we have not created VLAN 10, but if you assign an interface with VLAN 10, the VLAN will automatically get created. Okay, then the next thing, the same thing again. So interface FA0/2. Okay, switch port mode access VLAN 20. Clear, guys? Okay, now, yes, now we are gonna, yes guys, okay, now so let me connect it here. Let me connect the router to F0/10 of switch interface, and this is gig 0/0/0. Okay, yes, okay, now what we are going to do is we are going to create the sub interface. And one more thing, let me assign the IP address to the computer. Okay, suppose this is 192.168.10.1, suppose, and /24, and it is 100. Suppose the gateway is .100. Okay, so now again we'll go to the desktop. So this is 200 dot or 20.1. okay, and 20.100. Okay, now I suppose you do not have any doubts for this, right? Okay, then you will take the switch, sorry, you will take the router first. You will take the router and you're going to create the sub interface. So before creating the sub interface, you have to make sure that the physical interface is up bar up. This physical interface means the gigabit Ethernet 0/0/0. This interface is in up bar up state. That means you have to make it as no shutdown, or you have to configure no shutdown and make it as up. And also this interface should not have any IP address. It should not have any IP address. Clear? Okay. So now
IP address, then how will you give the gateway?
So here the physical interface does not have an IP, but the sub interface has an IP address. Getting it? So instead of configuring the physical interface, we are configuring the sub interface here. Clear? Okay. So now, so here we'll go to the router and we'll make sure the interface is up. So we'll go to the config mode. Sorry. Okay. We'll go to the config mode and we'll mention interface gigabit Ethernet 0/0/0, where we'll mention this or we'll configure no shutdown first. We'll make the interface up and we'll make sure that there is no IP address configured in gig 0/0/0. So do show IP interface brief. Okay, include 0/0/0. So now when you check it, it is unassigned. If at all it is assigned, you can give no IP address command. Clear? Then you will exit. Now that you are going to give the sub interface commands, so you will create a sub interface. Creating a sub interface is like this: interface gigabit Ethernet 0/0/0.1, or after the dot you will give a sub interface number. Okay, so now you can see interface gig 0/0/1 is changed to up, and the line protocol is also up. So we have created a sub interface. You can see the prompt has moved into config-sub if. That means we are in the sub interface. Now I told you we will mention it needs to be worked in, or it needs to work in VLAN 10. Okay, so the command is we will mention the encapsulation method also. Encapsulation dot 1q. Okay, and VLAN 10. Encapsulation dot 1q 10. Okay, that's the command. Then you're gonna give the IP address here. The IP address is 192.168.10.100. So what we are going to do is that we are going to give the IP. So IP space address 192.168.10.100. Okay, then 255.255.255.0. Done. Wow, it will come. So guys, for today you will have to adjust. Sometimes this will happen. Okay, so now it has come. So now the IP address you have set it for the gigabit Ethernet 0/0/0.1. Okay, this is the config, and now you are gonna do the second sub interface. Okay, so interface gigabit Ethernet 0/0/0.2. So a new sub interface has been created where you will mention the encapsulation dot 1q and the VLAN ID is VLAN 20. Then you will give the IP address. The IP address is suppose 192.168.20.100. Okay, done. That's it. Okay, now the last thing to do is that I told you. So here to the switch interface which is connected to the router, we will make this interface as trunk. Okay, so you will go to this F0/10. Okay, so here we'll go to, where is it, the switch. Okay, here we'll go to the switch interface FA0/10. Okay, so interface fastnet 0/10, where you will be giving the command switch port mode trunk. Clear? Now you're gonna get, so this is done. Okay, now if you check, now if you again, okay, yes, so now if you check from this computer, if you go to this computer and if you try to ping 192.168.20.1, Okay, one is the IP here, 20.1 is the IP, 20.1. Okay. If you try to ping, then you need to receive the reply. Shall we check? Yes, you can see you're getting the reply from 192.168.20.1. If you want to know the route, actually what happens is that, let me take, okay, so when I try to ping from this computer to this computer, it is not going directly like this. Instead, it will first go to the sub interface, gig 0/0/0.1, and then the router will check it, and the router will understand this network is connected to gig 0/0/0.2. Then it will be sending back through this interface and will be received at the machine. Clear? Okay. So this is how the packets are sent. So let me again show it to you. So let me execute the command trace rt 192.168.20.1. So you can see it has gone to 192.168.10.100, then 20.1. So it has gone to 10.100, which is gig 0/0/0.1. Then it has gone to the computer. Clear? So you can write down the commands. Do show history. So this is the command. And this is the switch command. Just a moment, let me connect. Let me take the command switch also, command of the switch. Okay, you can write it down.
Still there is more commands and here switch more access.
That was the pre-config. Pre-config in the sense that is already initially it needs to be done. And this you can do it. Say again in the router, you can make the interface up. Okay, that I suppose I didn't give it here. So gigabit. So you can mention it like this. Interface gig 0/0/0, then yes, no shutdown and no IP address. Okay, that's it.
You need to specify no IP address.
If at all an IP is configured, you can specify. If at all the IP is not configured, it's not necessary to specify it. Yes. Remote ഞാനിവിടെ മേടിച്ചു വെക്കാം. Okay, and I suppose both of you should be made, one should be made to sit here and the other should be made to sit here or here somewhere. Okay, those are the villains here. Okay, yes. I thought he might be good, but nope, not at all. That is already a villain. Yes, done guys.
Yes.
Okay, so now we shall go to the next one. So the next one is, okay, so the next one is switch virtual interface. You can write the heading switch virtual interface. Switch virtual interface. Here we'll be using a layer 3 device. I mean the layer 3 switch. We'll be using the layer 3 switch. Okay. Here, suppose you got a layer 3 switch. So this is the layer 3 switch, and suppose that we have computers. So F0/1, and suppose this F0/2. Now F0/1 is in VLAN 10 and F0/2 is in VLAN 20. Now what you can do is, so you got VLAN 10 and you got VLAN 20 here, and you will assign the IP address to the VLANs. You're going to assign the IP address to the VLANs. So you're going to assign the IP 192.168.10. Suppose 10.100/24, and here 192.168.20.100/24. So these are the IPs which we will be using. And then the IPs here, suppose this IP is 192.168.10.1/24, and you can set the gateway 10.100, which is the IP address of this it's not the sub interface, it's the IP address of the VLAN. Okay, now here again 192.168.20.1/24, and the gateway address is 20.100. Okay, now one more thing we need to do is that we need to enable L3 features. Enable L3 features in L3 switch. Okay, we will be enabling the L3 features because this is the L3 switch, and the L3 switch should be able to do the routing. You will enable the L3 features. So now let me just show it to you here. So let me delete these things, and let me place a layer 3 switch. This is the layer 3 switch or the multi-layer switch, and in the multi-layer switch we are connecting it to F0/1 and F0/2. Now F0, so let me do the pre-configs again. Interface FA0/1, switch port mode access, switch port access VLAN 10. Okay, interface FA0/2, switch port mode access, switch port access VLAN 20. Done. The pre-configs have been completed. Now what we are going to do is we will give IP address to the VLAN. The command is we will define the interface as, the VLANs as an interface. So the command is interface VLAN 10. Interface VLAN 10. We have created a VLAN 10 where we'll give the IP, say the IP address again. So the IP address here is 192.168.10.100 255.255.255.0. Okay, and it is up, and again we will give interface VLAN 20. They will give the IP address. IP address is 192.168.20.100. Clear? And at last I told you we need to enable the L3 features. So to enable the L3 features, the command is IP routing. The command is IP routing. Done. So after doing this, we are gonna try to ping from the computer to the other computer. So when we do it, again it may take some time. Yes, you are getting the output. Okay, and if at all you trace route, Yes, you can see it has first gone to the, say, VLAN 100, sorry, VLAN 10, IP address of VLAN 10, or switch virtual interface of VLAN 10. Then it has gone to the machine. Clear? Okay. This one also you can write on the commands. Do show history. These are the commands.
What actually happens when we set IP routing?
IP routing, so it will enable the layer 3 features, and it will also check the packets, and it will be like maintaining the routing table and much more. Okay, so this switch will be having the routing table. If at all, do show IP route, so you can see it will now maintain the routing table. Okay, yes. Clear? This is how we will do the InterVLAN communication. Now let me tell you the next thing. So again we got some more portions in the switching section, I told you. So we'll go, or we'll study. Now we'll go with a topic called port security. We'll go with a topic called port security. So you can write down the heading port security. Okay. Now, so before going to port security, shall I give you a figure, a homework figure? Okay, so here you can note down the homework figure. Okay, now you got another computer here. Now you got a router here. So F0/1, F0/2, sorry, F0/1, here F0/2, F0/2. Now this is in VLAN 100 and this in VLAN 200. This in VLAN 100 and this in VLAN 200. Okay. The VLAN 100 machines should be given with an IP 192.168.100.0/24, while VLAN 200 machines are given with an IP 192.168.200.0/24. So my requirement is this first machine should communicate to the second machine, third machine, and the fourth machine. Similarly, the fourth machine should also communicate to the second machine, first machine, and the third machine. Clear? Can you do it? Okay. Yes. So, yes. And hint, let me give you a hint. Yesterday I've told you to give the trunk and all, right? Here also you need to give the trunk. In some interface and all, you need to configure the trunk interface. Which interface and all, just think about it and do it. Okay, yeah. So this is the homework. Now we'll go with the next one. It's called port security. Port security. So port security, suppose you got a switch. We got a switch here. Now, yes, I suppose somebody has pinged. Yep. Okay. So suppose we got machines. Okay. Now, say you got machines like this. Say suppose it is connected to fastn 0/1 and fastn 0/2 here. And again, let me just configure the IPs here. 10.0.0.1. Okay, /8. Let it be /8. And here the IP, let it be 10.0.0.2 /8. Okay, now let me tell you here. So these machines will communicate with each other. Suppose these are the company machines, they will communicate with other organization machines, they will communicate with each other. If you try to ping from this .1 to .2, they will reply, or you will get the reply. Now suppose this guy can come up with his own laptop. This guy can come up with his own laptop and can connect a connector here. Can connect a connector or a hub, small hub here, and then can utilize the connection, or can utilize the connection to this PC, or suppose can misutilize the connection to the internet. So to avoid the misutilization, we are configuring port security. We will be configuring port security. So if you configure port security, the port security only allows one machine to participate in one interface by default. Okay, it allows only one machine to participate in one interface. That means suppose here it allows only one MAC address to be placed under one interface in the CAM table. I've taught you about the CAM table or the MAC address table. So in MAC address table, so if you have F0/1 interface, F0/1 interface, and if at all this PC2 is a legitimate machine and he's trying to communicate, it's an incoming frame to the switch. It is what? It's an incoming frame to the switch. So you guys know the incoming frames, source MAC address, the PC2's MAC address will be stored in the CAM table. It will be stored as, okay, say this PC2 MAC. Suppose this is PC2 MAC. PC2 MAC is present in F0/1. Clear? Now, if somebody else is trying to communicate, then this information is also sent to the switch, and the switch will know that already one guy is sitting and one more guy is sitting. Okay, so it does not allow more than one machine to sit under one interface. If at all another machine is detected, by default this interface will be made shut down. It will be made shut down. Clear? Okay, so now, so let me configure the, or say suppose, let me show it to you. This computer is now communicating automatic or communicating properly to the next computer. Ping 10.0.0.2. It is communicating to the other computer. Okay, and here again, this guy sitting over here can misutilize. Suppose he can come with this laptop. He can come with this laptop, and he can configure again. Suppose, oh again, it's really irritating, I know guys. Okay, if at all it is again, so okay, give me a minute. Suppose that someone has come with a laptop, okay, and suppose we are configuring this IP as 10.0.0.3, okay. Now, and he is connecting it to the hub here. Where is hub? He is connecting it to the hub, okay, and from hub it is connected to this interface. So let me tell you what happens here. So this machine, the laptop, will also be able to communicate. So here, if this machine is trying to communicate ping 10.0.0.3, this machine is able to communicate to 10.0.0.3. So again, this machine will also be able to communicate with 10.0.0.3. Sorry, this is 10.0.0.2. okay, so we have to ping to 10.0.0.2 only, guys. So 10.0.0.2. Any confusions? Okay, so here this guy will also be able to communicate to 10.0.0.2. okay, so now our intention is that these machines again, okay, okay, so these machines, so my requirement is that this laptop should not be able to communicate. Okay, for that we will configure the port security. So let me configure the port security here. We'll go to the switch and we'll go to the interface. We'll go to that specific interface. So the interface here is F0/1. You can see the interface here is F0/1. So we'll go to that interface. So interface FA0/1. Then we will mention the command. We'll first make it say access mode. Okay, because dynamic mode will not support it. Okay, port security will not say support the access, say dynamic mode interface. So let me show it to you. The command is switch port security is the command, and if you try to execute, it says command rejected. Why? F0/1 is in dynamic port, so you will have to convert to access first, okay, or trunk. So suppose that I am converting to access, switch port mode access. Okay, now we'll be doing the command switch port security is the command. Switch port security. So we have now implemented the port security. Now to view the things, or to view the necessary things related to port security, you have the command show port security. The command is show port security. If you check, you can see F0/1 is enabled with again port security. Okay, so guys, again okay, if at all it flickers again, let me restart the machine. Okay, restarting, I don't think that restarting will solve the issue. Even one day I remember, right, even in your class also I tried to restart, right, so that didn't happen. So let me again restart it. Okay, sometimes this happen, I'm not able to troubleshoot it, what happened here. Okay, so you can see the port security F0/1 is enabled in port security, and maximum secure address is the maximum address, or the maximum MAC address allowed in this interface is only 1. It means only one MAC address is allowed to sit in that interface. Okay, and in case of violation, in case of any violation, the security action will be taken. And what is security action? Shut down. Okay, the interface will be made down, shut down. Okay, so now let me show it to you. This is the legitimate PC, and let me check 10.0.0.2. He is able to communicate. Now if the other machine is trying to communicate, if this other machine is trying to communicate, ping 10.0.0.2. so here you can see the link is up. So if you try to communicate, you can see the link has gone down. It is because the violation mode is shut down. The interface will be made to shut down. If at all it is shut down, you can go to interface fast internet 0/1. To make this interface up, you need to give shutdown command. You need to manually shut it down. Then you need to give the no shutdown command. Clear? Okay. Now that, again, it will take some time for the interface to come up. Then, if at all the legitimate device is trying to communicate, it can communicate. While when the other device tries to communicate, it will become down. Okay. Now, what happens if at all, say, this has become down and the admin has made it down and again made it up. So what if again laptop tries to communicate? It will go down. Again, if multiple times laptop tries to communicate, multiple times it will go down. So again, the connectivity, this computer will say also lose the connection. So we have come up with another violation mode. So this violation mode is called protect. It's called protect. So if it is protect, let me tell you. So let me change the violation mode. We'll go to the interface FA 0/1, where we'll mention the command like this: switch port security violation. Switch port security violation. You can give shutdown is the default one. You can give protect. If you give protect, the existing machine will be protected. So here, existing machine in the sense this machine will be able to communicate while this machine will not be able to communicate. Their package will be discarded. So now let me again show to you here. This machine is able to communicate to 10.0.0.2. And now, what about this machine? This machine is not able to communicate. You can see it will show again request timed out. Okay. At the same time, when you check, does this interface has gone down? No. So that is protect. So now again the next command or the previous command, show port security. If you execute this command again, you can see the violation action is protect, and the violation count is 0. Here again, okay. So the violation count is 0. The violation count means say how many times the violation has occurred. So the violation count is 0 here. So now, if at all you want to execute another command, there is again a show and the show command. So show port security interface fast internet 0/1. Okay, if you execute this command, you can see the port security is enabled, the port status is secure up, and the violation mode is protect, and the violation count is 0. They are not going to take care of the violation count. So if at all you want to know the violation count, you will make this interface participate in restrict mode. You will make the interface participate in restrict mode. So to change the interface to restrict mode, we will go to interface fast internet 0/1. The interface will go and we will mention it like the switch port security violation, yes, restrict. The command is this one. Instead of protect, we will give restrict. Clear? Okay. Now again let me tell you. So in restrict, what happens is that if at all this machine, the legitimate machine is trying to communicate, he will be able to communicate. Now if at all this laptop is trying to communicate, it will not be able to communicate. At the same time, if you check do show port security, you can see the restrict mode and the violation count is 2 here. And if you check one more time, the violation count is now 4. We have tried to ping 4 times, so the violation has occurred 4 times. Now again, if you want, you can execute this command also, show port security interface fast internet 0/1. So now if you implement this or execute it, the port security is enabled, the port status is secure up, the violation mode is restrict, and the total MAC address is 1, or say here the maximum MAC address is also 1, and the violation count is 4. We have tried to ping 4 times. Okay, now so this is the port security. Now if at all you want to change it to say shutdown, you know it, right? Shutdown interface FA0/1, then you will mention the command like this. Instead of violation you can mention shutdown. Okay, if shutdown, you already know what happens. If this machine is trying to communicate, it will communicate. If somebody else is trying to communicate, it is, yes, the interface will go down here. Okay, now here the concept is that I told you the legitimate device, right? If the legitimate device is trying to communicate, he will be allowed. So did I configure any machine as a legitimate device? No. We haven't mentioned in the switch that this is the legitimate device. The concept is that whoever is trying to communicate first, their MAC address will be stored in the MAC address table or the CAM table. Whoever is trying to communicate second, it will not be stored. That's the concept. Let me again show it to you. Okay, here let me configure no shutdown. Okay, first let me configure shutdown and let me configure no shutdown. Okay, now so if at all this laptop is trying to communicate, okay, if you do not have, do show MAC space address hyphen table is the command to view the MAC address table. If you check it, MAC space address hyphen table. Okay, so nobody is there in the CAM table. If this computer is trying to communicate, now this computer is able to communicate. Clear? Why? Because yes, the laptop's MAC address is now stored in the CAM table. The laptop MAC address is 07CA. If at all now the legitimate device is trying to communicate, the interface has gone down, or it will not let this machine now to communicate. Clear? So again you can mention the MAC address, you can mention the legitimate device, which is the legitimate device. So to mention the legitimate device, again let me make this interface up. So shutdown and no shut. Okay, so now to make this as legitimate device, okay, we can mention the MAC address of the device. What we can mention? We can mention the MAC address of the device. So here we'll go to the device here, interface FA0/1, where we can mention the MAC address. So the MAC address is, say, you will mention it like this. Okay, switch port security, MAC hyphen address, then the MAC address of the device. So if at all the MAC address of this device, suppose let me check it, IP config hyphen or /a/all. So suppose this is the MAC address of the device. Where is it? This is the MAC address 9415. This is the MAC address of the computer. So you can mention it like this. Okay, you can mention the switch port security MAC hyphen address 9415. You can mention it manually, but here, okay, duplicate MAC, so it is there. So let me just delete this. Okay, and let me just give another computer. .192.168.10. say suppose, sorry, 10.0.0.1, right, 10.0.0.1/8. okay, so now if this machine is now trying to communicate, okay, so we'll mention the IP config space/all. okay, so this is the MAC address here, 3CD1. you have mentioned this 3C D1 MAC address. Now in the do show MAC space address hyphen table, this 3C D1 MAC address is already present. Okay, if at all this machine is the laptop is now trying to communicate. If at all the laptop is trying to communicate, the interface will go down. Okay, so let me show it to you. So you can see the interface is going down because we have already mentioned which is the legitimate device, and only that device will communicate now. Clear? Now, so what is the advantage of mentioning it manually? If you mention it manually, say all the manual configurations, it will be there in the MAC address table. Moreover, say whatever you mention it manually, it will be there in the switch. It will be there in the switches running configuration. Okay, so do show run interface FA or interface gig, sorry, FA 0/1. Okay, include 0/1. Okay, sorry, section 0/1. You can see the interface 0/1 is configured with this MAC address, which is configured statically. We have mentioned it statically. Okay, now what is the advantage if it is there in the running config? If it is there in the running config, you can save it. You can save it. You can save it as the startup configuration. If you save it as the startup configuration, if at all the router reloads, these configuration will be still present and only that machine will be communicating. Clear? But again, let me tell you. So suppose that you got multiple computers here. You got hundreds of computers here. So to manually mention all the MAC address of the computer is again difficult. Right, so it is difficult. So what we have come up with is that we have come up with certain configuration called MAC address sticky. What is called MAC address sticky? Okay, so let me remove it. Let me remove it and do show MAC space address hyphen table will not show anything. Nobody is there in the MAC address table. Okay, and no configuration is also there. So you do not have any MAC address under F0/1. Now we will configure the MAC address sticky. The command is switch port security MAC hyphen address sticky. This is the command. So if at all you have mentioned the sticky command, let me tell you what happens. If you mention the sticky command, when this computer is trying to communicate to this device, okay, its MAC address will be automatically added to the running config, or its MAC address will be automatically sticked to the running config. Clear? Okay, so now let me show it to you here. So before that, again, let me change the switch port security violation, let me change it to restrict. Okay, because or if it is shut down, it will keep on going down again. So I'll have to again one more time, I'll have to say make it down, again make it up. Okay, so here now if you check it, ping 10.002, let's see what happens. Something has happened. Oh, this is already down. Okay, so let me make it up. No shut. Okay, and so if this computer is trying to communicate, now this computer will try to, or this computer will get the communication. Feeling sleepy? Okay, so no worries. Okay, we are almost to the end of this port security. Okay, so now if this laptop is trying to communicate, it will not be able to communicate. Okay, so it is going on, so the request timed out. Okay, now let me tell you. So here when you check the running config, do show run section 0/1. So you can see MAC address sticky. I've just mentioned the MAC address sticky, and this MAC address automatically, yes, it came automatically been sticked into the running configuration. So this is the MAC address sticky config. Clear? And the last one, the last thing about say port security is that suppose if your requirement is to make both the computers communicate. Okay, it means your company or your organization has allowed you to come with your laptop and use the internet or use the resources. So then both these computers should work. So I told you by default only one machine will be able to communicate. Okay, now it can be changed. If at all you want two machines to communicate, you can change it like that. Shall we? Okay, so now we'll go to the interface and we'll mention switch port, port security, maximum. By default it is 1. Now that we will give the maximum as 2. If you give it as 2, then 2 machines will be able to communicate. This machine is already able to communicate. Now if at all this laptop needs to communicate, it will also communicate. And the third machine will be blocked. Clear? Any doubts? Okay. So this is the port security. So then I'll give you a break till 6:32, 33, 34, 35, 36, 37. Okay, or 38. Clear? Oof. It's not a single person, and now I can't see Susmit. That's the problem. Okay. Okay. So the commands, guys. This is the command. Do show history. Okay. No switch port MAC address. So let me show it to you. So I'll be sharing these commands. No worries. Okay. So let me pause record. So now, okay, sometimes I'll forget. Okay, now, so here Etherchannel. So here suppose that you got switches like this. You got 2 switches, S1 and S2. S1 and S2. Okay. Now suppose you got F0/1 connected here and F0/1 connected here. So suppose again you have multiple computers. You got multiple computers here. So this fast Ethernet will be able to send and receive only 100 MB per second. Okay, so 100 megabits. What if you have, say the computers are sending together, they are sending 100 and say 5 Mbps. In a second they are sending 105 Mbps in every second. So the problem is that there will be congestion. There will be congestion. Okay, so a lot of say frames will get congested here. Okay, so the problem is that so you will face congestion. So here also you will face congestion, and this congestion is called bottleneck congestion. Bottleneck congestion. To avoid the congestion, can you suggest me a way? Can you suggest me any method? Yes? You can use gigabit. Okay, that is one. Okay, yes. And range. What range? Waiting. Okay, you are telling that they need to wait. So if they wait, they will have to wait. Suppose again, say what if this data is like getting again, say suppose they are sending everything is 200 Mbps they are sending. Okay, it's double now. Okay, again, so they'll have to wait. So it will keep on increasing. Every second the data will keep on increasing. And there is a queue limit. Of course, there is a queue and there is a queue limit. The problem is that congestion will again increase. So obviously one method is that you can use gigabit Ethernet interface. But what if the switches are not having the gigabit Ethernet, or they only have the fast Ethernet? Okay. Now let me tell you, you can add another interface. You can connect one more interface. Okay, so you can connect F0/2 and F0/2 or 3 or whatever. Then the load balancing will happen. The load balancing will happen. Getting it? Okay, the load balancing will happen. No worries guys, say this concept will be over within say 20 minutes. Okay, and maybe after 20 minutes I can leave. Okay, so now, so here the load balancing will happen. Will it happen guys? Yes or no?
Yes.
Yes. Anyone having a difference in opinion? Will the load balancing happen or not? So, yes or no?
I'm not sure.
Not sure. He has changed the plate. Not sure. So, if at all yes, then what is the reason? If at all no, what is the reason? If at all not sure, what is the reason? Why you are not sure? What makes you tell that it's not sure? Yes, Deva. I suppose it is because that I have asked you twice. Is it? Anyone? Guys, the spanning tree will block it. Right? If you have multiple path. So suppose that this is the root switch. So S1 is the root switch and S2 is the non-root switch. So root switch. Okay. So all the interface of the root switch will be designated port. Okay. And suppose this is the root and this will become blocked port. Right? So if you connect another interface, it will become blocked port and no traffic will be passed through that port. So the result, even if you connect multiple interfaces, say everything, all the interfaces will get blocked here. So it will not have any effect. Okay, so here we need to load balance. At the same time, you need to say the spanning tree should not block it as well. You need to load balance as well as the spanning tree should not block it. For that, you will do the configuration called Etherchannel. You will do the configuration called Etherchannel. So in Etherchannel, let me tell you. So in Etherchannel, what you're going to do is that you will tell the switch, hello switch, you may have physically 2 or 3 interfaces, but consider those interfaces as a single interface. Consider all those interfaces as a single interface. Okay, even if you have F0/1, F0/2 and F0/3 connected from switch 1 to switch 2, do not consider it individually, instead consider it as a single interface. And that interface is called port channel. That is called port channel. Suppose port channel 1 or port channel 2. Consider it as a single interface called port channel. So what happens is that the spanning tree will be considering it as a single port channel. While at the same time, so you will have multiple, physically you will have multiple interfaces. So the load balancing will happen at the same time. The spanning tree will not block it. Clear? Okay. So now let me show it to you here. Say here you have the packet tracer. Let me show it to you here. Suppose I'm taking 2 switches. Switch 1 and switch 2. Suppose this is S1. Okay. S1 and this is S2. Okay. Now let me connect it. Let me connect it from 1 to 1. Okay. 2 to 2. Okay. Maybe after some time you can see. So this interface is getting blocked. You can see this is amber color, orange color. It is getting blocked by the spanning tree. And again, if at all, if I connect again, say 3 to 3 and 4 to 4, everything will get blocked by the spanning tree. Okay. So again, let me show it to you. You can see those are again control. You can see the orange or the amber color here, right? Those are blocked by the spanning tree. Okay. If you check it, say let me connect it like this. Okay. So one more, just give me a moment. So you can see 3 interfaces are in the block state. So if you check it, you can see show spanning tree. You can see F0/1 is in forwarding state, that is the root, and the others are 2, 3 and 4 are in block state. Clear? Okay. Now we are going to do the Etherchannel configuration. So to do the Etherchannel configuration, you can configure it using 2 ways. first you can configure it manually. You can configure it manually. If you want to configure it manually, it is called on mode. It's called on mode. You are making the Etherchannel manually. So that's called on mode. You are manually making it on. Okay. So let me tell you how to create the Etherchannel manually. So here we'll go to the range of interface. So interface range FA0/1-3. We have gone to the range of interface, or it is four. We have connected 4 interfaces. Okay, so we have gone to the 4 interfaces together. Then we will shut down. Okay, we'll make the interface down, because say if at all the interface in the real switches, if at all you do not make it down, there are chances that the loop can occur, and also there are chances that the switches will misbehave. Okay, so for that to avoid, I'm just shutting it down. And then I will mention the command channel-group. Then let me give a number. So here I might have told you the port channel 1 and port channel 2. So these are the numbers, the interface numbers. Okay, so channel-group 1. Then I'm going to mention mode on. Then you can see creating a port channel interface, port channel 1. A port channel 1 is create. Okay, now to configure the next switch, again we'll go to this switch here. We'll go to the range of interfaces. Interface range FA0/1-4. Then we'll mention the command switch port. We'll first shut it down. Then we'll mention the command channel-group. Then the group number is 2. Suppose we are giving the group number 2. Then mode on. Okay, then after giving this one, we will make these interfaces up together. Okay, here also we will give no shutdown, and here also we will give no shutdown. Together we will give no shutdown. Okay, so here no shutdown. Clear, guys? Now after some time you can see all these interfaces have come up. Okay, and let me show it to you here. It's in S2. Okay, so S2, you can check do show span or do show spanning-3. You can see, so it is connected to the next switch using port channel 2 interface. Now the spanning tree is not considering the individual interfaces, but they are considering a single interface, which is the port channel 2. Clear? Okay, now you can see, so the port channel here, the entire port channel here. Now if this is the root switch, this has become the designated, and this has become the root. Clear? Now if at all you want to make it as a trunk, you can go into the port channel. Okay, you can go to the port channel here. Suppose interface port channel say 2. Okay, interface port channel 2. Then you can mention say switch port mode trunk. If at all you want to make it as trunk, you can mention switch port mode trunk. You really don't have to go to individual interfaces and configure that. You can configure it together like this in the port channel interface. Clear? Okay, so this is how you're going to configure the port channel manually. And you got some show commands. The first show command is show Etherchannel. Okay, so in the I suppose I have accidentally created, so here it is S1. In S1 I have created only, say here I have accidentally created a port channel 2. Okay, we do not have a port channel 2, we have made it the port channel 1 here. I have accidentally created the port channel 2, that is why it is showing 2 port channels. Okay, so now just leave it. Okay, now you can see the port channel 1, it is in L2. Okay, that means it's the part of the switch interface. Now 4 ports are connected, F0/1, 2, 3 and 4. Maximum port 8 ports are supported. Okay, and port channel 1 and protocol, it's nil. We haven't created any protocol, we have manually created. Okay, and again one more show command, show Okay, if you do this, you can see port channel 1 is connected, port channel 1 is there, and SU, S means here you can see it's in U means it's in use. Okay, S here it means layer 2 in use now. Getting it? Any doubts? Okay, okay, now you can see the port channel 1 consists of the interface F0/1, 2, 3 and 4. These 4 interfaces are bundled in the port channel. Clear? Okay, so this is how you do the configuration. Now again, so now you have created it manually. Okay, now if at all you want to create it using some protocols, you want to create it using some protocols. So let me take away all the commands here. Okay, let me take away all the commands. Do show history. Okay, so let me first know interface port channel 2. Okay, and let me go to the interface range FA 0/1-4. Okay, then mention, let me just shut it down. Okay, and mention this as no channel hyphen group. Let me just delete whatever I have configured, because manually we have done it. Okay, so let me just delete whatever we have done. So the manual configurations are gone now. Okay, so now again let me go to the next switch where I'll be deleting all the configs. So do show run, so do show history. So now let me shut it down and mention this one. Okay, now that I've deleted all the commands there. Now if you want to create the ether channel manually, okay, if I execute this command, do show ether channel. Okay, so again let me delete the port channel here. Okay, no interface port channel 2. Okay, and let me go to a switch, no interface port channel 1. Okay, everything has been reverted back to the same. Okay, if you check do show ether channel, you do not have any ether channel here, you do not have any port channels. Okay, do show ether channel summary, you do not have any ether channel or port channel. So in the next switch also the same thing, S2, do show ether channel, you do not have any ether channel. Now that we are gonna create the ether channel, say again using protocols. So here you can create, you got two protocols. The first is called PAGP. It's called PAGP, Port Aggregation Protocol. Port Aggregation Protocol, which is Cisco proprietary. We do not have that to study. Okay, and the second one is called LACP, Link Aggregation Control Protocol. Link Aggregation Control Protocol. This is developed by IEEE. It's developed by IEEE. PAGP and LACP. Okay, now, so now you're going to do the LACP here. You're going to do the LACP. So LACP, if you implement, you got two modes. So static, I told you, so static configuration or manual configuration, the mode was called mode on mode. Okay, now in LACP you got two modes. You can configure one as either active, one is active mode, and the second one is passive mode. One is active mode and the other one is passive mode. Okay, active and passive. Suppose that you got two switches. Oh, done, almost done, guys. Okay, suppose you got two switches, S1 and S2. Suppose you are implementing the LACP. Okay, so LACP you can implement, and one phase should be in, at least one should be in active mode. Okay, it can be, so one should be in one link, or one end should be active mode, and this end can be active or passive, no issues. Active or passive. Clear? Okay. So now let me show it to you. Shall we configure?
Yes.
Okay. So now let me go to switch 1 and then create the Ether channel. So we'll go to the range of interface range fast Ethernet 0/1-4. Okay, then we'll mention the command. Say first we'll mention the protocol. So the command is channel-protocol. Channel-protocol. Then we'll mention the protocol LACP. Protocol is LACP. Then the next command, channel-group. Channel-group. Then the group number, the port channel 1 we are going to create, so group number 1. Then mode, we are going to give active or passive. Suppose we are going to give active here. Clear? Okay. So we have created the interface. So here we have created the port channel 1. We have created port channel 1, and make sure you make the interface down. It is already down here. Okay, previously I have made it down. Okay, similarly we are going to give, so these are the commands. We have just mentioned the protocol, and we have just mentioned the, say, whether it's active or passive. The same thing we are going to do in the other switch also. Okay, so we are going to go to, so yes, switch 1 we have configured. Now switch 2 we are going to go to the next switch, and we are mentioning interface range fast Ethernet 0/1-4, where we will be giving the protocol, the command channel-protocol LACP. Channel-protocol LACP, and then channel-group. Then suppose we are creating Ether channel 2, then 2 or group 2. Okay, then say mode, passive or active, you can give anything you can give. So that now that I am giving passive. Clear, guys? Now they will automatically become, say, the Ether channel. So now shall we make it up? Okay, so no shut, and again let me go to the next interface here. Okay, so no shut. I made the interface up. So now if you check it, show Ether channel, you can see, the port channel 2. Now maximum ports 4 now. The ports configured are 4. Maximum port 16. LACP supports maximum port up to 16. Okay, now the next command, show Ether channel summary. Ether channel summary. You can see port channel 2. Okay, and the protocol is LACP, and F0/1, 2, 3 and 4 are in bundled in port channel. Clear? Any doubts? Okay. So this is how you are going to do the Ether channel configuration. Okay. Yes. Do you want to write down the commands?
Yes.
Okay. Again, so let me show the commands here. I suppose we'll have the command somewhere, Ether channel, yes. So this is the Ether channel commands. Configuring the Ether channel manually, and configuring the LACP and the show commands. Okay, we got some more things here. Tomorrow you will study those things. If you want, you can take a screenshot and share it in the group, or if at all you want, you can take a, say, photo and share it in the group. Okay. Yes. So let me pause recording.